Hello, in this video we will go over one type of example that covers a word problem modeling with linear equations. So we will be working out of the book, so you might want to get your book today. This is an example of a geometry problem. If the length of each side of a square is increased by 3 centimeters, the perimeter of the new square is 40 centimeters more than twice the length of the original square. Find the dimensions of the original square. So this is a typical geometry problem, and by typical we mean it deals with perimeter. So there's two ways you can set these perimeter problems up depending on what kind of information you have. So the first way, you'd have an algebraic representation of perimeter equals a numeric value for perimeter. The second way, you may have one algebraic representation of perimeter equal to a second algebraic representation of perimeter. So let's look at this problem again, only this time we're going to draw a picture. Now what you notice is as you read through here, you don't ever see a value given for the perimeter. Nowhere in here does it say the perimeter is 80 centimeters or some such thing. So what we're going to try to do is set up one algebraic representation of the perimeter so we can set it equal to a second algebraic representation of the perimeter. So our original square is the little one. And remember, a square just means we have four sides that are all the same. And our new square, it says up here in the first sentence, we're increasing the side of the square by 3 centimeters. So that's where I got x plus 3 from. Now the next part of the example tells us the perimeter of the new square, that's the bigger one, is 40 centimeters more than twice the length of the original square. So I make an equation out of that. How do I describe the perimeter of the new? How do I describe the length of the old? Well, we called the length of the old one x, and the new one then would be 4 times x plus 3, because that's side plus side plus side plus side. So I have 4 of the same thing, equals, and the 40 plus 2x came from the description in our example. So there's the equation we need to solve. Now when we solve this, we're going to solve for x, which if you remember is the length of the side of the original square. So we work that out, and we find the original square is 14 centimeters by 14 centimeters. And we're done.